Hello everyone, welcome to my channel. In this video we are going to learn about the introduction to the linked list. So in this video we are going to learn about the introduction to linked list, array versus linked list, and the linked list in the C language, and the different types of linked list, that is a single linked list, double linked list, and circular linked list. So these topics we are going to cover in the next upcoming videos. And what are the different operations that we can perform on the linked list, like so the basic operations are insertion, deletion, and traversing through the linked list. So these are some basic operations that we can apply on the linked list. So in addition to that, we can apply the comparing of two linked lists and merging of linked list, reversing a linked list, and sorting a linked list. So these are the different types of operations that we perform on the on the linked list. So this we will see in the next videos. So now let us know about what is a linked list. So here the name itself denotes that linked list. So here a list which is linked to another list. Okay. So a linked list is nothing but it is a chain of items. It is a list or chain of items where each item points to the next one in the list. Okay. And each item in the linked list is called a node. Okay, so here the list means a node. So here number of nodes are connected to each other through a link. So we can traverse through the linked list using a pointer. Okay, so here the list means a node. Okay, so each item in the linked list is called a node, and each node contains the data and also the location of the next item. So here this is a node with the data and the pointer to the next location or to the next node. So here the linked list means a list or a node which is linked to another node, simply saying, right? And the data can be here the data in the linked list can be of any form, like it may be of a integer kind or array, a structure, or even another class object. Okay, so similar to how we store the homogeneous data elements in the array, similarly we have to store the homogeneous elements in a particular linked list. So a linked list is a data structure which allows to store data dynamically and manage the data efficiently. So here we are going to store the data dynamically and manage the data efficiently. So why we are using the term called dynamic data structure for the linked list? So in the case of the array, so here I want to store the data regarding the 10 students. Then I have to mention array of 10, right? So if you mention like this, then the compiler will create a array with the 10 memory allocations, right? So this is the static data structure. The array is a static data structure because we are already mentioning how much amount of storage we require. But here in the case of the linked list, so there is no need of mentioning the amount of data required. Okay, so the compiler will dynamically allocate the memory required by the user, requested by the user. Okay, and here to manage the data efficiently means, so here a linked list can grow and shrink in size during its lifetime. So that means there is no maximum size for a linked list, and the nodes are stored at different memory locations in the computer. Okay, so that's why it is called as the linked list is the data is dynamically stored and managed efficiently here. The linked list is a data structure which in turn can be used to implement other data structures like stacks and queues. So using this data structure, that is the linked list, we can implement the other data structures like stacks and queues. And a linked list can be perceived as a train or a sequence of nodes in which each node contains one or more data fields and a pointer to the next node. So if you observe a linked list, it will be like a sequence of nodes, or it will be like a train. So how the train coaches will be connected to each other through a link. So similar to that, the nodes in the linked list will be connected to each other through using a pointer. Okay, so here using a pointer they are connecting to the other nodes. Okay, so in the linked list we are having the certain features here. So a pointer called header points to the first element of the list, right? So here it points to the first element, right? So we are having the header that points to the first element of the list, and the null variable denotes the end of the linked list. Okay, so here the starting of the linked list is pointed by the header, and the ending of the linked list is pointed by the pointer, that means null variable. Okay, and each node is connected to another node using the link or pointer. Okay, and here if you want to traverse through the linked list, so based on the header address only we can traverse to the linked list. And that means if you want to access the node B here, okay, so we can't directly store the address of B. Instead we are going to store the base address of the header. Okay, so using that base address we can traverse to the linked list. So here the header plays a key role. Okay, and here the successive nodes are connected by pointers. That means each node is connected to another node by a pointer, and the last element points to the null. So that means the end of the linked list is denoted by a pointer variable. Okay, so basically we are using the ASCII character 0, or we can use the ASCII character -1 to denote the null variable of a linked list. So it can grow or shrink in size during the execution of a program. A linked list may grow or shrink during the execution of a program. So here if you observe the arrays, so arrays will be having some certain fixed amount of storage. So the compiler will provide some fixed amount of storage. But here in the linked list, so it can grow or shrink. So that means we are not estimating the size before allocating the nodes for a linked list, right? So here that it is dynamically allocating the nodes for the user. It can be made just as long as required. So that means there is no maximum size for the linked list. Okay, so we can add as many number of nodes as we require for the linked list, and it does not waste the memory space and consumes exactly what it needs. So in the case of the array, if you consider array of 100, that means so it is going to store the data for the regarding the 100 students here. Suppose 10 students dropped from the school, then there will be only 90 students only will be there. So that means so the 10 locations will be wasted, right? So we are going to store only 90 students data in the particular array. So here the 10 students, that means 10 locations will be wasted. That is if you are using the arrays. But in the case of the linked list, it will dynamically allocate the memory required by the user. So now let us see the differences between arrays and linked lists. So why we are going with the linked list than the arrays? So here array is a contiguous memory location, right? So here the data will be stored in a sequential manner, in a series or sequential manner in the memory location. So here the base pointer here is the array name. So based on the base pointer we are going to traverse to the array. But in the case of the linked list, so here there are sequence of nodes. So here the nodes are connected with each other using the pointer, and here the nodes will not be in this sequential manner. Okay, so it will be, the nodes may be stored anywhere in the computer. Okay, simply there will be a pointer. Suppose here the address of the 15 is, so here the address of 15 is 200, and the address of 10 may be 1000. Okay, so here the the first node will store the address location of the 15 here. So 15 may be present anywhere in the computer. So based on the address stored in the link or pointer location in the node, so it is going to point to the particular location of the linked list. Okay. So similarly, the second node 15 is going to store the address of the 20, and similarly the 22 is going to the fourth node is going to store the data 22 and the location of the address 25. So like that it is going to point to the next node. Okay, and here the last node. So this is the end of the list, because so it is not pointing to any other node. Okay, so that's why we're representing with the null variable. If suppose a particular node, there is a particular node, so which is having a null value. Okay, which is having a null value. That means the header is empty. The linked list is empty. It is not storing any nodes. Okay, so if the header is of the null value or empty type, that means in the linked list there is no data stored. Okay, so this is about the arrays versus linked list. That means how we are going to store the arrays. So arrays, in the case of arrays, the data will be stored in a sequential manner, and the data we are going to store here is finite only. Okay, but here we can store as infinite amount of data using the linked list. So now we will see the differences between the arrays and linked list. So in the arrays, elements are stored in a contiguous memory allocations, and arrays are static data structures. Okay, and they are suitable for inserting, deleting of an element at the end, and randomly accessing an element, searching the list for a particular value. But whereas in the case of the linked list, adjacency between any two elements are maintained by means of a links or pointers, right? So here the two nodes are linked using a pointer, and it is a dynamic data structure. So these are the linked lists are suitable for inserting an element at any position, deleting, and applications where sequential access is required, that is traversing the linked list, and in situations where the number of elements cannot be predicted beforehand. That means, so in the case of the linked list, we can store infinite amount of data, but whereas in the case of the arrays, we are going to store only finite amount of data. Okay. So why we are going with the linked list means, suppose I am taking in the case of the arrays with the 4 memory locations. Okay, so here already data is inserted 3, 2, 5. Okay, so here I want to insert an element, that is 7, in the particular array. Okay, so I want to insert the element 7 in the first position. So this is the 0, 1 and 2, right? So in the first position I want to insert an element. Then I have to move all the elements to the next memory location. So here I have to move 2 to the next location and 5 to the other location. Okay, so if there is memory space in the particular array, then we can move the elements to the next memory allocation, right? So after moving the elements, then we can insert the value 7 here. Okay, so 3, 7, 2 and 5. So in this manner we can insert an element. So here the storage is of 4 units only, right? That means, so here we are storing the integers and of the 4 memory locations, that means 12 bytes. So for 12 bytes it will be easier to move the elements. Suppose if you are storing the elements of 100, okay, the array of length 100, then it will be 100 or 1000, then it will be difficult to move all the data to the next location. So that's why we are going with the linked list. So in the linked list we can easily insert and delete an element without swapping the elements in the memory locations. Okay, so that's why we are going with the linked list. And linked list will provide the flexibility and performance both better than the arrays. So this is about the introduction to the linked list. Thanks for watching my video. Please like, share and subscribe to my channel. Thank you. So now let us see how to define a node of a linked list. Okay, so in the linked list we are having a node, so with the data and the next field, that points to the another node in the linked list. So using the pointer in the node, we can traverse to the next field in the linked list, right? So here, how to define a node, that means how to create a node. Okay, so in the node we are having two elements, right? So each structure of the list has a node, and the node consists of two fields, that is the data and the next element. So next data means the item that we want to store in the particular node, and the next field, so next means it is going to denote the address of the next item in the linked list, right? So it is going to store the address of the neighboring node, okay, or it points to the next node in the list. So simply saying, it is going to store the neighboring node's address in the next pointer. So how to define a node of a linked list? So in the C language, we are going to define the node of a linked list using the structures. Okay, so here I am taking the node, struct node. Okay, so I am defining so since I'm going to create a structure of node with the elements, data and the next. So here the data and next. So as we told earlier, the data may be of any kind, of integer or character kind, or it may be an array, or it may be another structure or any object also, right? So since I am going to store some data which is of integer type, so I am taking the int type data and struct node star next. That means, so we are going to denote a pointer here. Okay, so we are defining a pointer, that is star next. So here the next is pointing to the neighboring node. So it is going to store the address location of the neighboring node. Okay, so in this way we can define a node in a linked list using the structure. Suppose a linked list is not having any neighboring nodes, so it is having only single node in the linked list. Okay, so such structures which contain a member field pointing to the same structure type are called self-referential structures. Okay, in a linked list which is not having any other nodes, only a single node is there. So this will happen in the case of the circular linked list. Okay, so in the single linked list and double linked list, so a node will point to another node, but the end of the linked list, that is there will be null variable. But in the case of the circular linked list, there is no null variable. Okay, so the end of the linked list is connected to the header variable. So at that case, so these self-referential structures will play a key role. Okay, so it will be of the kind, so data and the next location. So it is going to point to itself, right? So in the linked list there are no other nodes, so there is only single node which is pointing to itself. That is called as a self-referential structure. So here we have to denote another pointer. Okay, so I will take a pointer like struct temp variable. Okay, struct node temp. So that means, so we are taking another variable that points to itself. Okay, so this is how we can define a node in a linked list. In upcoming videos, we will see what are the different types of linked lists and what are the operations that we can perform on a linked list.